So, hello students. So again, we're going to start about module 2. So we discussed a little bit about water pollution in the previous module, which is module 1. But we will just brush about the concept of water pollution a little bit, and then we'll go for some important terminologies and like COD and BOD and how to determine them. So water pollution, as we have discussed, that any contaminant that reduces the quality of the water to use and it is unfit for human or any other organisms. So that is called water pollution. So there are two different kind of water we know. The polluted water we know, that is one is sewage, that is coming from domestic or municipal area. But one it is coming from the industry, we call it as a effluent. Then the sign of water pollutions are the following. So you can see that bad taste, the bad smell is coming out. You can see floating well, or you can see the formation of weeds, a huge amount of weeds. Then the causes of water pollutions are in many ways. We can see that, or we heard about that in the previous video, that if you can produce waste like biological waste or radioactive waste, or even like a discharge of effluents from the industry area, dumping of other biological waste from the hospitals or household, or even agricultural waste that could be pesticides or insecticides or any other things, or even the fertilizers, which all can contribute to the water pollution. We already have seen that classification. There are many chemical pollutions, physical pollutions, and biological pollutions. The physical chemical pollutions, they change that quality of the water in terms of pH. It can add to a lot of organic materials like carbohydrate, fats, polymers. Physical pollutions may be through how it appears to be, like it's a color, it could be odor or taste. And biological pollution, basically it's like throwing some feedstocks or cow cells or vegetable products from the animals to the particular area, which can cause to the bacteria and produce a formation in virus and animal. Okay, the sources and effects of water pollution. So sources, as we have discussed, it could be infectious agents, oxygen demanding of organic waste, inorganic chemicals like fertilizers, organic pollutants like organic compounds, it could be plastic, pesticides, plant nutrients like that is phosphates and nitrogen compounds, radioactive pollutants, and the effect could be adverse because if you drink all this all this wastewater or polluted water, we can cause serious health problem. Infectious agents, we have seen the protozoa, bacteria, and all these microorganisms that we have discussed. We're not going to go through it. Oxygen demanding waste are those which basically needs or require oxygen to digest. Inorganic, that different toxic metals that can be lethal to our human health. Organic chemicals are basically oil, gasoline, plastics, pesticides, and all these detergents that industry people use. And the effects I already mentioned, that it would cause the damage to the nervous system, cancers, and it can kill the disease. Plant nutrients is basically ammonium and phosphate containing materials or the fertilizers. And when we cannot drink this because it can cause a lot of cancers, or it can kill even the infants. And at the same time, it can produce a lot of unwanted aquatic plants, which will reduce the oxygen in the water. The radioactive pollutants are basically coming from mining or nuclear power plants. That the severe problem is that it can cause cancer and can damage the immune system. Source of pollutions, water pollutions, we already discussed. One is point sources, we know where exactly coming from, and non-point sources, we don't know exactly where from where does it come. So that picture we already discussed. This is the non-point sources. So during the rain, from where does it come? We don't know. Just about the rain of what it was. Control measures, basically we should stop throwing things in water or even in the soil, because soil compared to the contact water can also leach into that water, and that can also cause problem to that. You should not just throw the waste into that water bodies, and the public awareness is very much required. At the same time, the government also should impose strict rule against those who violate ordinance. Okay, so now we're going to talk about the chemical oxygen demand. So chemical oxygen demand is basically that that if you have a chemical, organic chemical that can be degraded by uh, the microorganisms. Okay, and to survive all these microorganisms, they need oxygen. So how much oxygen need to digest all this organic material present in wastewater is actually the measure of chemical oxygen. Okay, it is given by that the mg of oxygen per liter. So basically the total organic matter when it consumes oxygen and then it produces CO2 and water. Okay, it is a rapid test and we require 2 hours of incubation. That's very important. So you can finish your test within 2 hours. Therefore, it is a rough estimation, so it is not a good estimation. Okay, the process is the following. So you have a sample water. You can take potassium dichromate and sulfuric acid, and you can just reflux it, okay, so that you can see this reflux condition. Then you do the because this dichromate, what will happen? This dichromate will be uh, changes to chromium 3. From this will reduced, and this will be oxidized. Okay? And then whatever the amount of chromium you need, you remaining, that you can do the titration with the ferrous ammonium sulfate, so which will be oxidizing itself and reduce the rest of the potassium dichromate in the system. So that by amount you can basically see what is that concentration of the dichromate. If you know the initial amount, you can easily calculate the amount you have. Another way, you can actually directly check that the UV spectra of that particular solution, because that chromium has a particular absorption wavelength. So if you monitor the height, which is the like absorption equals to epsilon CL, which is a Beer-Lambert law. Just by simple putting of the values in the equations, you can calculate easily that amount of chromium 3 plus present in the cells. Okay, so this is very straightforward, very simple method. It's not that much problematic. So basically, what happens in your organic matter, potassium dichromate, and in presence of sulfuric acid, a little bit of catalyst that would produce chromium 3. And ammonium ferrous sulfate is basically used to determine the amount of dichromate remaining. So if you know the initial amount and what is remaining, you can easily calculate how much consumed, and that for the organic matter oxidation. Okay, so you can use a particular indicator and you can easily count what is the amount of dichromate you need. Okay, the other way, so when you do the reaction, it will produce the chromium 3. Chromium 3 absorbs over here, so you can basically directly check. So this is the absorption over here. So that I was saying number Beer law, absorption equals to epsilon CL. You know the epsilon, you know the absorption from this particular value here, the y-axis, and then C is the length of the sample holder or sample vial, and then we directly get the C value, so how much is producing. So this is very much important. So there are also some method is that chemical oxygen demand. So there you actually can do the calibration as well. So you know the individual sample amount, okay, and then you can basically check, you know, the concentration of the organic materials. You can add it, and then you measure the data, and you get a calibrated curve, okay, and then you have an unknown sample. You measure wherever it fits. You draw the line at the bottom, and you can get immediately the amount of uh, that oxygen or the oxygen. What is called the amount of organic matter present in the water. So this is very simple method. It is not that much. Now the biological oxygen demand is basically it is a natural process. So where you need to have the organic materials that can be degraded by the biological organisms. Okay? So if you probably you have seen somewhere that sometimes that the water in the lake is black. It is because there is a lot of microorganisms are there which digesting that organic material present in that particular lake or water. Okay, so this is a natural process, and this is in the BOD, which is biological oxygen demand, was first developed in 1930. Okay, the goal of the sewage treatment is stabilize the organic matter. So basically, when you think about the purifying the water means you have a lot of inorganic, organic, and radioactive materials, and you have to remove all the things, and then you can use it or reuse it. And that is in all developed countries they're doing it. They don't like use the groundwater every day, which we don't follow that. Okay, we should always treat our wastewater and produce the clean water and use it. So that should be the proper way of handling the use of the natural resources. But we don't. Okay. So basically, the standard test is an incubator for organic materials. In this ways, is also known as biological oxygen demand. So basically, the biological oxygen demand requires it tells about that if you have a biodegradable materials in your wastewater, how much oxygen is required for this microorganism to digest the water. So that is what it is. Biological oxygen demand is basically commonly expressed the same way, milligram of oxygen per liter. Incubation time is 5 days. So because it is a biological process, it is a slow process. It's a chemical process, you can do it immediately. Okay? The temperature is kept at 20 degrees, where basically the efficiency of this microorganism is very fast. So BOD is basically that is determined at time 0, whatever the dissolved oxygen you have, and the minus the dissolved oxygen at T, 5 days. Okay? So where the D is the dissolved oxygen. So by this equation you can basically find it. And this is a very nice curve that actually tells. So this is what exactly what 5 days happen. So you can till extend until 20 days. Okay, but this takes very long time and very slow process. So within 5 days, mostly 60 to 70% reaction occur. And rest of the time is actually required for the nitrogenous compound composition, which basically is slow process, and that's why people don't go for that long. And if you really want to know everything, so you should do until 20 days. But even though you cannot reach 100%, so still there is some time required, or there is something which cannot be removed completely. Okay. So this is what most of the reaction happen within 5 days, and most of the biological demand amount is the waste is actually consumed by the particular materials. So there are two different methods for two methods actually. One is the regular methods or the ionometric method, and the one is the membrane electrode method. So we are going to talk about the ionometric method, how it is actually operating. So basically, that to determine that particular using the electron method or ionometric method. So basically, dissolved water measure is based on the fact that the dissolved oxygen oxidizes the potassium iodide and liberates the iodine. Okay, that is a very simple first reaction. The liberated iodine is titrated against the thiazide solution using the starch as an indicator. But here, before going to the particular reaction, so this is the what actually the reaction I was discussing on first two, something happened here. Basically, use magnesium sulfate in basic condition that reduce the magnesium. So basically, since the dissolved oxygen in water is molecular state, it cannot oxidize the Ki to the iodine. So basically, for that we need atomic oxygen. For that, the manganese dioxide in turn is oxidized by the action of potassium hydroxide on manganese sulfate. So basically, that manganese sulfate in presence of potassium hydroxide produce the manganese hydroxide, and then it reacts with the oxygen, produce manganese oxide and water. This manganese oxide again reacts with sulfuric acid and produce atomic oxygen. So this is the most important thing. Okay, and you can see for one atomic oxygen requires 2 moles of manganese hydroxide. Okay, and then they react with the potassium iodide, and then you produce the iodine, and this iodine now titrated with the sodium thiosulfate. Okay, and then we use the starch for that particular indicator. So basically, iodine starch gives you blue color. When all the iodine is gone, you produce that iodide. There's no color; it's colorless. Okay, so you have to find out the color. So basically, 1 mole of oxygen reacts with the 4 moles of carbon. So whatever the thiophenes you get, you divide it by 4, that gives you the amount of oxygen you have in space. So is it quite a good equilibration here to it is a very standard procedure. At the same time, it requires time and patience to get the particular amount of dissolved oxygen present, which is biologically the organic materials, waste materials that can be biologically degraded. Okay, so that if you compare the BOD and COD, so is organic matter oxidized to CO2 and water by microorganisms. COD is the organic matter oxidized to CO2 and water by the chemical oxidation. So that is two different things. Advantages of the COD is a very much faster. So within 2 hours you can get the results. So BOD takes a very longer time. But COD, it actually gives a rough estimates and it oxidates everything whatever you had in there. But BOD gives only a little bit, only 60% of the results, but the rest 35% doesn't. But that 65% is very accurate. Okay, so that is what exactly the difference between these two. Now, what is TDS is a total dissolved solid. So basically, you have organic materials that can be chemical oxidized or biological oxidized, but you have a lot of minerals. Okay, so that what it is called total dissolved solids. So all the mineral salts of calcium, magnesium, sodium, potassium, whatever salts they are all considered in the particular level. So there is some acceptance level is there. So 300 mg per liter is very good, excellent, and then when you go beyond that, it actually slowly reduces the quality. And when it reaches the more than 1200 mg per liter, that is acceptable and okay. Determination of TDS is like it's a lab work method. So basically, you take 1 liter of water and then you evaporate the water. And if you know the empty flask and after evaporation of water, you take the weight and subtract the value. You can immediately get the corresponding the quantity. Instrumental method is basically measure conductivity, assuming that most of them can conduct electricity. Okay, that is one of the assumptions, but it is not always true. Okay. The another method is the atomic absorption spectroscopy or ICP-AS. So that is very important and it's very expensive technique. So we are not going to discuss about details, but that gives you a very accurate number of what contaminants different metals. Okay? And it requires a lot of standardization, so very expensive methods. So